Hello, I'm Dr. Ashish. Welcome to my channel Live Biochemistry. In this video, we will discuss about the part 3 of the chemistry of lipids, and we will discuss about the classification of lipids. Okay, this classification of lipids, it is as such, it is asked in 10 mark long question. Okay, while its sub classification, there is a one topic called as a phospholipid. Okay, that is also separately asked in a 4 or 6 marks. Okay, you can visit my website www.livebiochemistry.com, okay, where you will find the study material including PowerPoint presentation, MCQs, case discussion, justification, etc. Okay, so guys, please visit my website www.livebiochemistry.com. So coming to the classification of the lipids, so lipids are classified into the simple lipids, complex lipids, and derived lipids. Okay. Now we will see what are the simple lipids. So depend on the type of the alcohol, these simple lipids are further subclassified into the neutral fats and wax. In neutral fats or oils, here the alcohol is glycerol, while in case of wax there is other than glycerol. It may be mainly the monohydric alcohol is present in the wax. This neutral fat is also known as a triglyceride, okay, which is a storage form of energy. Okay, this triglyceride is stored in the adipose tissue, and whenever we require the energy, this triglyceride is broken down to glycerol and fatty acid, and we get the energy. While the wax is mainly used in the cosmetic and pharmaceuticals. Now coming to the second classification, that is complex lipids. In complex lipid, this is the ester of fatty acid with alcohol with additional the prosthetic group. So based on the prosthetic group, they are the further subclassified into the phospholipid, where along with the lipids, there is a phosphorus group is there. Then there is a glycolipids. So along with the lipid, there is a carbohydrate group is there. And in case of lipoproteins, other than the lipid, there is a protein part is there. So the compound lipid has a fatty acid, alcohol, and the additional group. And they are classified into the phospholipid, glycolipid, and lipoprotein. Okay, this phospholipid, it is further classified into the glycerophospholipid and sphingophospholipid. In glycerophospholipid, the alcohol is glycerol, while in sphingophospholipid, alcohol is sphingosine. Okay, so this glycerophospholipid, the example is phosphatidylcholine, which is also called as the lecithin. Okay. Then another example of glycerophospholipid is phosphatidylethanolamine, which is also called as the cephalin. Then phosphatidylserine, phosphatidylinositol, cardiolipin, and plasmalogen. So these are the example of glycerophospholipid. While in sphingophospholipid, there is only one example, that is sphingomyelin. Okay. In glycolipid, there is a cerebroside, globoside, and ganglioside. While in case of lipoprotein, the example is chylomicron, high density lipoprotein, low density lipoprotein, and very low density lipoprotein. Okay. This phospholipid is further subclassified into the glycerophospholipid and sphingophospholipid. Okay. The example of glycerophospholipid is phosphatidylcholine, okay, which is also called as the lecithin. Then phosphatidylethanolamine, which is also called as the cephalin. Phosphatidylserine, okay, phosphatidyl'inositol, cardiolipin, and plasmalogen. Okay. So this is the examples of glycerophospholipid. While the example of sphingophospholipid is sphingomyelin. Okay. So you can see here in glycerophospholipid, the alcohol is glycerol, while in sphingophospholipid, the alcohol is sphingosine. Okay. You can see here the structure of glycerophospholipid. There is the glycerol is the alcohol. To the first carbon, fatty acid is attached. Second carbon, there is the fatty acid is attached, and to the third carbon, phosphate is attached. This is the basic structure of glycerophospholipid, and this whole structure is called as a phosphatidic acid. To this phosphorus, various groups are attached, like choline is attached, which is called as the lecithin. like ethanolamine group is attached, it is called as a cephalin, or serine may be attached, or inositol may be attached, or to this phosphatidic acid, where is the glycerol, okay, to the glycerol 2-phosphatidic acid is attached, it is called as the cardiolipin, and there is a one more is plasmalogen. While in case of sphingophospholipid, there is a sphingosine group, to that there is a fatty acid attached, so sphingosine plus fatty acid, sphingosine plus fatty acid, it is called as a ceramide, okay, and to the ceramide, if phosphorus and choline is attached, it is called as a sphingomyelin. So we will see the structure. So sphingosine, it is a 18 carbon amino alcohol. Okay. You can see this is 12 carbon here, 12 carbon, this is 13, 14, 15, 16, 17, 18. So it is a 18 carbon, there is a hydroxyl group at 1 and 3rd, so it is a alcohol, okay, and there is a at the second carbon, you can see here, this is the second carbon, there is a amino group is there. So it is a 18 carbon amino alcohol, that is a sphingosine. Sphingosine is nothing but it is a 18 carbon amino alcohol, and it is made up of 16 carbon palmitic acid, okay, and 2 carbon serine, okay. With these two compound, the sphingosine is formed. To this sphingosine, at the second carbon, where there is the amino group, to the amino group, if fatty acid, okay, if fatty acid is attached, it is called as a ceramide, okay. So ceramide is sphingosine, okay, plus fatty acid, right? That is ceramide. Okay. So you can see this is the 18 amino alcohol. At the second carbon, there is the amino group, and to that amino group, if fatty acid attached, it is called as a ceramide. And in the first carbon, if phosphorus group attached and choline group is attached, it is called as a sphingomyelin. Okay. So to the ceramide, if phosphorus and choline group, okay, if these two groups are attached, it is called as a sphingomyelin, which is a very important part of our myelin sheath. Okay, so this myelin sheath is made up of the sphingomyelin. So the phospholipids are classified into the glycerophospholipid and sphingophospholipid. In glycerophospholipid, alcohol is glycerol. In sphingophospholipid, alcohol is sphingosine. To the sphingosine, if fatty acid attached, it is called as a ceramide. And to the ceramide, if phosphorus and choline group is there, it is called as a sphingomyelin, which is an important part of our myelin sheath. Okay. In case of glycerophospholipid, there is the example is phosphatidylcholine, phosphatidylethanolamine, serine, phosphatidyl'inositol, plasmalogen, and cardiolipin. So we will see each of these one by one. So first is phosphatidylcholine. Okay. As we have already seen the structure, there is a glycerol molecule. Okay. In glycerol, first carbon is fatty acid. The second carbon also fatty acid is attached. Then the third carbon, there is a phosphorus group. This whole compound is called as a phosphatidic acid. Okay. Now to this, if choline group is attached, choline group is CH2, and here there is a 3-methyl group. Okay, that is phosphatidylcholine, which is also called as a lecithin. Okay. So the importance of lecithin is it is an important part of our cell membrane. You can see this is a cell membrane. Okay, this is the exterior part, this is the cytosol, this is the cell membrane. So this cell membrane is made up of phospholipid bilayer, and lecithin is a major component of our cell membrane. Okay. Now the clinical applications are two. Okay. One is that is frequently asked in 2-mark question and Viva also, that the snake bite lead to the hemolytic anemia. So what would be the reason? Because the snake bite contains the phospholipase A2. Okay. This phospholipase A2 will break down lecithin to lysolecithin and fatty acid. And because this RBC membrane, the integral part is lecithin, so the membrane structure will be damaged and it will lead to the hemolysis. Okay, hemolysis. Another clinical application of the lecithin is lecithin act as a lung surfactant. Okay. Frequently asked question that premature baby are more prone to the acute respiratory distress syndrome. Why? Because lung pneumocytes start producing this lung surfactant called lecithin from 28 weeks of the fetus life. Here, the conversion of pneumocyte 1 to pneumocyte 2, steroid play a very important role. Once the pneumocyte 2, it will produce the lecithin. Okay, so pneumocyte in the alveoli will produce the lecithin, and it will decrease the surface tension. Okay, inside the lung, and by that it will increase the pressure inside the lung and prevent collapse of the lung. Okay, but in preterm baby less than 28 week, this lecithin is not produced, so there will be increased surface tension and there will be decreased pressure inside the lung, so lung will collapse. That is called as the acute respiratory distress syndrome. So the baby, preterm babies, they are given the steroid as well as surfactant. Okay, and as such, there is a lecithin that is in the form of dipalmitoyl lecithin. Okay, so dipalmitoyl lecithin is produced, and dipalmitoyl lecithin to sphingomyelin ratio, if it is more than 2, it is suggestive of lung maturity. These are the two clinical applications of the lecithin. One is in the snakebite hemolytic anemia, and second is preterm baby more prone to the acute respiratory distress syndrome. Okay. Then second is cephalin. The other name of cephalin is phosphatidyl So here to the phosphatidic acid, you can see this is the glycerol, fatty acid and phosphate. This is the phosphatidic acid. To the phosphatic acid, ethanolamine, CH2, NH3. That is the ethanolamine. That is attached. It is called as the phosphatidyl ethanolamine, or it is called as the cephalin. It has a very important role in the blood coagulation. Okay, our blood coagulation factor 3 is produced from the cephalin. Then phosphatidyl inositol. So you can see this is the structure of phosphatidic acid. To that, if inositol is attached, it is called phosphatidyl inositol. So we know that phosphatidyl inositol, it is converted to inositol diphosphate and diethylglycerol, which has the role as a secondary messenger system in mechanism of action of hormones. One more is phosphatidyl serine. Okay, you can remember phosphatidylcholine, that is called lecithin, phosphatidyl ethanolamine, which is called as the cephalin, phosphatidyl inositol, and phosphatidyl serine. Okay, 4 will start from the phosphatidyl, and serine has a role in the program cell death. It has a role in the apoptosis. Okay, serine has a role in the apoptosis. Then fifth is a cardiolipin. Cardiolipin is also called as a diphosphatidyl glycerol. So to the glycerol, this is the structure of glycerol, CH2OH. To the glycerol, two side, if phosphatidic acid, that is, okay, so CH2OH, fatty acids, and phosphorus, that is the phosphatidic acid. So if phosphatidate or phosphatidic acid to phosphatidic acid attached to the glycerol, it is called as the cardiolipin. It was first isolated from the heart, that's why it is named as the cardiolipin. It is present in the inner mitochondrial membrane. Okay, inner mitochondrial membrane. The clinical application, if the woman has a cardiolipin antibody, and it will lead to the frequent abortions. Okay, if cardiolipin antibodies are present, it will lead to the abortion. Then the last in the glycerophospholipid is plasmalogen. Okay, here in plasmalogen there is a alpha beta unsaturated alcohol which have a ether leakage. Okay, the first hydroxyl group of the glycerol. You can see here, this is the alpha beta unsaturated alcohol. Okay, there is an ether leakage. This is called as the ether leakage. Ether leakage at the first hydroxyl group of the glycerol. That is the plasmalogen. It is also called as the platelet activating factor. It will activate the platelet, so it will be helpful in case of bleeding. So we have seen in phospholipid so far, there is a glycerophospholipid where alcohol is glycerol. Okay, example is phosphatidylcholine, that is called lecithin, phosphatidyl ethanolamine, which is called as a cephalin, then phosphatidyl serine, okay, and phosphatidyl inositol, then plasmalogen and cardiolipin. Okay, so these are the part of glycerophospholipid. Lecithin is a part of our cell membrane and act as a lung surfactant. Okay, prevent collapse of the lung. Ethanolamine, or also called as cephalin, has a role in the coagulation. Okay, has a role in the coagulation. Phosphatidyl serine has a role in the apoptosis. Phosphatidyl inositol has a secondary messenger system in mechanism of action of hormone. Plasmalogen is platelet activating factor. It will activate the platelets and help stopping the bleeding. Cardiolipin, it is a part of inner mitochondrial membrane. Okay, so this is all about the glycerophospholipid. And another was sphingophospholipid. Sphingophospholipid, where there is a sphingosine group is there instead of glycerol. There is a sphingosine group is there, and to the sphingosine, there is a fatty acid attached. That is called the whole structure is called ceramide, and to the ceramide, phosphorus and choline is attached. It is called the sphingomyelin. Okay, this is all about the phospholipids. So you have to mention both the glycerophospholipid and sphingophospholipid in case of phospholipids, which is a frequently asked question. Now, so glycolipid do not contain the phosphate group. Instead, with the lipid, carbohydrate group is attached. Okay. So these glycolipids, they are high in the nervous tissue. The type of glycolipids are fibroside, globoside, and ganglioside. Okay. So these glycolipids, okay, the basic structure is the alcohol in glycolipid is sphingosine. Okay. This sphingosine, you can see it is a 18 carbon amino alcohol. Okay. And to this sphingosine is fatty acid attached, it is called as the ceramide. Now to this ceramide, if one carbohydrate, one monosaccharide is attached, either glucose or galactose, okay, to the ceramide, if either glucose or galactose is attached, it is called as the cerebroside. So this is the first classification of glycolipid, it is cerebroside. If glucose is attached, it is called glucose cerebroside. If galactose is attached, it is called as the galactose cerebroside. And if both glucose and galactose, okay, both are attached to the ceramide, okay, glucose and galactose, both are attached to the ceramide, it is called as a lactosyl ceramide, which is also called as a globoside. Okay, this cerebroside, they are important part of our gray matter of the brain. Okay, while this globoside, they are present in the RBC membrane. Then third is a ganglioside. Okay, so to the ceramide, glucose, galactose, okay, and if additional nana and acetylneuraminic acid, which is a 9 carbon, which is made up of pyruvate, which is 3 carbon, and mannose, which is a 6 carbon. So pyruvate and mannose, they will form the 9 carbon. It is called as the N-acetylneuraminic acid. If this N-acetylneuraminic acid is attached to the ceramide and oligosaccharide like glucose and galactose, this whole structure is called as the ganglioside. Okay, so you can see ceramide, glucose, galactose, and nana. So this structure is called as the GM3. Now, if 2 nanomolecules are attached, it is called as the GD. If 3 molecules are attached, it is called GT. If 4 molecules are attached, it is called GQ. Okay, and to this glucose, galactose, nana, if one more N-acetyl galactose is attached, it is called as the GM2. Okay, and if additional, okay, galactose will be attached, it is called as the GM1. This 1, 2, 3 is based on the electrophoresis mobility. As GM3, it is the lowest, lower molecular weight, so it is the highest electrophoresis mobility, so it is called GM3. Okay, this structure is called GM3. But if N-acetyl galactose is attached, it is called GM2. If galactose is attached, it is called GM1. Like that. Okay. This ganglioside will contribute to the stability of the pheranodal junction and ion channel clusters in myelinated nerve fibers. If there is autoantibodies to the GM1, will disrupt the lipid raft and pheranodal or nodal structure in the peripheral motor nerves. Okay. So this was about the glycolipids, where there is the example is cerebroside, globoside, and ganglioside. So now the last we have seen in the complex lipid, there is a phospholipid, there is a glycolipid, and third is lipoprotein, where to the lipid additional protein part is attached. Example is chylomicron, very low density lipoprotein, low density lipoprotein, and high density lipoprotein. Then the third classification is derived lipids. We have seen about the simple lipids, where the example is triglyceride and wax. Complex lipids, the example of complex lipid is phospholipid, glycolipid, and lipoprotein. While the derived lipids, they are derived from the lipids, either from the simple or complex, or they will be the precursor of the lipids. The examples of the derived lipids will be the fatty acids, steroids, cholesterol, vitamin A or vitamin D. Okay, so everything which are derived from the simple or complex lipid, even the glycerol is called as a derived lipid. Even the monoacyl glycerol or diacyl glycerol, they will be called as the derived lipids. So this is all about the classification of lipids. Okay, so you can see they are classified into the simple lipids. Simple lipids, example is triglycerides, wax. Then we have a complex lipid. Complex lipid, example is phospholipid, glycolipid, and lipoprotein. And last is derived lipids. Example is fatty acid, cholesterol, vitamin A, vitamin B. Okay, the steroid hormones, bile salt, they all will be called as the derived lipids. Okay, this phospholipid is further subclassified into the glycerophospholipid and sphingophospholipid. In sphingophospholipid, there is a sphingosine group, and in glycerophospholipid, alcohol is glycerol. In glycolipid, the alcohol is sphingosine. Okay. If someone asks about what are the sphingolipids, what is sphingolipids? Okay, if they ask about the sphingolipids, what should be the classification? Sphingolipids, they are subclassified into the sphingophospholipid, example is sphingomyelin, and another is glycolipids. Okay, where we have to mention about the cerebroside, globoside, and ganglioside. Okay, you can watch my video about the sphingolipids. I will share the link in the description also. This is all about the classification of lipids. I hope you find this video helpful. If you like this video, please hit the like button, share this video to your friends, subscribe to my channel, and press the bell icon so that you can get notification for the future video also. Thank you friends for watching. Bye.